Yeah, I guess we'll get started. It's a little sparse in here, but welcome everyone who's online. And thank you. Today we have ZHOU, who's an associate professor in the computer science department here at Columbia, and also a co-founder of a startup, ArcLex.ai. And a list of many accomplishments, but maybe just a few to note. She was featured on the Forbes 30 Under 30 for Science. Recently also awarded Columbia's Provost Junior Faculty Award, amongst many other accomplishments. So yeah, we're excited to hear what you have to talk to us today about. And yeah, the floor is yours.
Okay, thanks a lot. So today, sorry about I'm still sick for an international travel. So today I'm mostly going to talk some of the work that we have been doing within my lab and also within my startup. Um, so if you look at, we're going to focus mostly on AI agents. And then if you look at Gen AI applications, most of the time we've seen people working on foundation models like OpenAI, Anthropic, or people working on research, which is where my lab was, on how do you convert these foundation models for specific applications with fine-tuning, reinforcement learning, continual learning, and so on. So here, particularly, is like how do you synthesize data? How can you use the data to fine-tune these models in order for various applications, such as like computer use agents, coding agents, and things like that. And then, of course, without fine-tuning, you can still use vanilla large language model and orchestrate them together to make agents. So, and then there's usually orchestrate layer that are, you can consider them the middlewares that you can leverage so you don't have to rebuild the wheels, such as a memory control module, such as FAM0, tool use connection and protocols like MCP, or you have like a vector database or information extraction, fine-tuning pipelines, testing and automated testing processes as well. And then, of course, security and guardrails. So, for example, my company, ArcLex, was mostly focusing on automated testing and evaluation for agents. Agents has a lot of vertical applications, and how to build these vertical applications really centered on how can you know your user groups really well? How do you design UI UX that would fit their processes and everyday workflows? And finally, how can you verify they are getting efficiencies or getting value out of these applications? How do you measure these usage back to how do you map that into ROIs, basically return on investments. So we've seen a lot of times when people are talking building agents, a lot of them building agents, but they stay as demos. So MIT review says 95% of the agents are still stay demos. So let's look at some of the real deployed cases and how they are actually different from the ones that are stays in demo. So this is an agent that was Walmart built for their Sparky agent. So Walmart agent is a shopping assistant agent. If you haven't used Walmart Sparky agent, you could also try Amazon Rufus agents. They're very similar in terms they're shopping agents. So how the shopping agents work is you can consider them as a shopping companion. So ChatGPT was also serving similar things, but Walmart really has all the catalogs that connected to their agents. So things are much more smooth in terms of pulling out your profile information, like the name, ask you for more proactive questions, and then you can get these kind of situation-based recommendations. Also connect to reviews and on the Walmart pages, and then be able to do clarifications, connect to product cards, and refine your search results. Uh, the agent also proactively asks you questions about reducing the scope of a recommendation. So here is another example of voice agents. It's a demo, actually. It's not an deployed one. We actually changed the name of the credit cards and the company as well.
Jordan from IP. How can I help you today?
Hi, I'm interested in getting a credit card and one that fits my lifestyle.
Absolutely. I'd be happy to help. Could you share what types of things you usually spend on or any features you're looking for?
So I order a lot of food delivery, especially through Uber Eats. I shop online often, usually Amazon, and I occasionally book travel. I want something flexible when it comes to redeeming rewards.
Thanks for sharing. Based on that, I'd recommend the Emerald Preferred Card. It's a great match for your habits. You'll earn 3 times points on Uber Eats and DoorDash, 5 times points on travel booked through iChase Travel, $50 annual hotel credit, free year of Dash Pass, 60,000 point welcome bonus worth up to $750 when used for travel.
Sounds good. How do I redeem the welcome points?
Your points are fully flexible. You can redeem them for travel, cashback, statement credits, Amazon purchases, and more. Would you like to apply?
Yeah, could you help me with the application?
Of course. I've just sent you a secure link via SMS. Follow the steps, and I'll be here if you need help.
Amazing. Thanks so much.
Awesome. You should hear back in 3 to 7 business days. Enjoy your new perks. Hi, Alex. Just reaching out to let you know your Emerald Preferred Card has been approved. Congratulations.
Thanks. We talked about a few benefits earlier, but I forgot the details on the travel rewards. Could you remind me how that works again?
Absolutely. You'll earn 5 times points on any travel booked through iChase Travel. Plus, you'll get a $50 hotel credit each year.
Got it. What's the annual fee again?
It's $95, but most customers easily cover that with the welcome bonus worth $750. The rewards are also flexible. You can redeem points for cash, gift cards, Amazon, or travel.
Whoa, amazing. Okay, can I activate the card now?
Sure. I've just sent you a secure activation link via SMS. Let me know if you need anything.
Yep, got it. It's activated.
Great. If you have questions about rewards or Dash Pass, just text or call anytime. Enjoy the perks.
Thanks a lot, Jordan.
You're welcome. Have an awesome day.
So here we see there's a voice call, and then they are also connected with SMS. So there are multiple actions that are happening during the call in order to be able to fulfill the task. So we can also see it's a calls, right? After the first session, we noticed that the credit card is approved, but the current customers hasn't really activated. That's why we sort of proactively reach out again to remind them why you opened this card, why you wanted to actually activate the card and start using. What are the perks that you could actually receive? So why are these agents very difficult to deploy, which is really the bottlenecks of agent evaluation. So single term evaluations are usually used for machine learning, which is you have a data set that curated that you have what's your X and what's your input and what's your output Y. Well, however, look at these kind of conversations. Whenever your system's response changes, your next turns the users of your agent's next turn will change as well. So this kind of interaction is going to actually really change if your systems change over time. So it really requires interactive testing instead of a curated data set that just you run in batch and offline. Another thing it's about because right now these agents have tool costs. For example, if you look at the conversation, it looks perfectly fine, but maybe they didn't provoke the tools. For example, the SMS message wasn't sent out. Or if you're returning an item, the database did not change. Your return wasn't successful. And then all of these things happen together. You wouldn't be able to test your agents' robustness very well. So nowadays, most of the people have been doing is looping humans for the testing. But human testing is usually very, very expensive, and also it has low coverage. It's imagine that Chase, for example, has so many different customers with different dialects, different language behaviors, and different wants and needs. So how it's very difficult to ask a product manager to recruit these people for testing or ask people to pretend to be these people and validate the system. So what we do is we create a digital version of these real users so that you can actually call them at any time. We start with some samples of real user and then do interpolation of these users to find intermediate users or slightly different from these users in order to cover much better testing space. And these users are still, you can consider them as agents. They are user agents or a digital twin of your real user that can be interacted and invoked at any time when you're testing your agents. So by having these agents, you're basically creating synthetic data with your agent. And then use this, you can have a more scalable in terms of testing and a very fast and on demand in terms of annotations of why your interactions are not good and how can you actually improve it. Oh, sorry. So here's an example. Sorry, let me play a different. Here's an example of how the agent, the digital twins were performed. So looks like a CLI tool. Once you spin it off, you'll be able to generate different personas with respect to your user agents. And then with respect to your users, you will interact with each other and be able to generate a list of conversations based on that. So for example, here we invoked a user called question, which is a director of operations, and the company called US Fleet Co. And it has traits as strategic, outcome-oriented, and budget conscious. And the goal is really to understand rental plan, negotiate product pricing, confirm monitoring, and deploy checklist. So you can see once you selected these personas are considered as digital humans. They will interact with agent interactively to create these kind of interactions. And then we'll run LLM as judge to evaluate individual turns and be able to give you feedback on how things work. Over time, we'll see you will be able to discover errors. And then if you run a large number of conversations, you'll be able to get more systematic reports telling you how much tasks are completed, how much of things are, how many errors we find, and then based on these errors of root causes, how you can actually improve your agents. Let me see. Coming back. So here is an example of how we design it. So we look at like what kind of ideal customer profiles of your agents are. Basically, what kind of users would interact with your agent? What's your agent's capability? What kind of business information do you have? And based on this, you have profile, goals, and info. And then you have like detailed these information. And finally, you will interact with these agents interactively and then generate conversations. And then on top of it, we'll run LLM as judge. Because we have the goals and we have the infos of the company, so it can narrow down with respect to this particular user and particular goal, what kind of knowledge was required in terms of doing evaluation. So we'll also add this kind of knowledge inside in order to do LLM as judge. Any questions? Okay, we can also take the question in the end of the conversation. So for example, let's take a return policy issue validation. So we created these synthetic user and we create a lot of purchase histories attached to this synthetic user. So for example, how I want to check my order status. And the agent say, hi, I see you have two recent orders, A and B. And then the synthetic user's goal is to get order status. So he will actually pick the ones that he really is looking for. And then based on this, the agent replies, is still pending fulfillment, which means it hasn't shipped. And then as a user, he needs to know when, for his like real intent, he really needs to know when he can get the item. So given the history, he's going to pretend, he's going to say, can you tell me when it might arrive in Seattle, given the context. So it's more realistic. And the agent still says, I'm sorry, but I have not exact shipment date, right? This is with respect to the user, that it's a red flag because the agent wasn't providing the information it really needs. So we will provide an issue saying that the agent cannot access to the shipping information because that was the information that was missing. So then the developer can go back and fix this issue. So even if the user agent wasn't satisfiable, but for a real user, usually he would still try to do it one more time and say, can you give me the customer service email, which is like reverting to human services. I say, I'm sorry, but I can't provide the customer service email, right? So this triggers another bug that we detected that's saying basically the agent doesn't really have customer service email information or like a backend information in order to make it work. So after all this kind of interactions and running in parallel, you'll be also looking into like per conversations, what are the outcomes look like? Did the agent able to complete the task that the customer required? Does the agent able to do it in an efficient way? Is the agent able to complete the call to action? Sometimes it's not only what agent want to supply answers to the user, but it's also the agent needs to user to do certain things. For example, subscribe to our mailing list and things like that. We also want to evaluate if the agent was able to persuade people to do that. So we have deployed these kind of this research converted product into with multiple customer. For example, one of the largest education company in Pearson, we're able to help them to build their customer service agents using the evaluator. So they will be able to simulate different students who plan to take tests in different locations with different needs in order to find all these edge cases. One of the things that we really do see in the future work that we're planning to is about how can we not only tell people there is an issue, but also help them to improve their agents. So not only doing evaluation testing, but also be able to give them agent flow change suggestions, prompt optimization suggestions to make it work. So for example, we have like these kind of missing rack knowledge, missing tools, and bad tools that we can correct. Um, so here is an example of before and after. So for a before, we build some people, the more junior agent, junior developer may be building a customer service email by saying, oh, giving once we get the user's detailed information of purchase, if the user wanted to return order, then we call return order tool. If the user wanted to cancel order, we call the cancel order tool. However, sometimes users don't know whether their product has been shipped or not. All they want is that they no longer want the product, right? So for some of the cases, if you build this simple diagrams, you'll encounter this problem that people say, I want to return my order, but he really means that he didn't want the product anymore. He did not know that the product hasn't shipped. But if the product hasn't shipped, if you call the tool return order, you will get an error, right? At this point, it can only do cancel order. But the user at this point, like he doesn't know, right? Nobody really looking at your tracking histories, right? So in this way, that you will get these kind of error. But the right way to do this in terms of automatic fixing is whenever people call a return order, you have to check if the order status is fulfilled or unfulfilled. If it's unfulfilled, it goes into call cancel order. And then with a specific information that the order hasn't shipped, but we can cancel order for you. Well, if it's fulfilled, then it can call the return order. Right. So building agents is very complex. You would always run into these edge cases you never thought about you need to design if you're a novice agent builder. But having these digital twins that have realistic interactions in mind, that helps you to find these errors quickly and be able to help you to improve your agent is very essential. One other thing that we see is more and more agents are getting more and more wanted to adapt to individual users, right? Imagine like Walmart or Pearson, they're interacting with so many different users in the end of the day. So they usually have to adapt to individual users, picking out their perks that they really need. So that requires the agents to be able to remember history of the user, being able to do personalization. So a lot of my research is focused on reinforcement learning, particularly how to select, given the user's preference, which particular strategies or offerings would actually convert users better. So in this, you can consider it's actually a search process. We actually did some research on using multi-color tree search to optimize towards a selection of different strategies in order to improve the final conversion rate of the conversational agents. So once we started the simulator work, is to help people to be able to find errors quickly, originally, and then but later on, it can also use that to create synthetic data to be able to bootstrap your reinforcement learning algorithm. So in this way, your reinforcement learning algorithm hasn't to start doesn't have to cold start, because if you haven't deployed your agents, you don't know how your end user will perform. So you don't know how to do personalization, but you can actually train with our simulated user, and that will be a jumpstart of how you deploy in the future. Finally, also is we know like these large language model based agents are very expensive. Also, if you have a lot of people using it, you would have to do provisionings on the resources on the cloud, which is also very expensive. But if you have digital users that you can use it for forecasting of traffics, then in this way, you can do it more auto scaling to help saving cost as well. Of course, when you're generating these kind of synthetic data, you can also use it for distilling smaller models during the operations. So you don't have to use large language model for every component, every smaller component of your agents. So I'll probably stop here and then take any questions.
I'll get you a mic.
We have one question in the room.
Mm-hmm.
Hello? You can hear me?
Yes.
Oh, okay. I had a question. I have a background in financial services, and we had set up many customer service call centers years ago and moved a lot of it overseas. And I've been more on the investment side recently. So we've invested in companies like UiPath and some of these larger customer service business process automation firms. And one thing that we found in trying to use this was sort of the training aspect of it, because especially in financial services, we had to be very careful in terms of the scripting, in terms of what information was provided to the customer, and then what you can actually tell them. So I guess I have a few questions. One is, do you see this as an opportunity for training, especially if you have access to, what they always say is that this conversation may be recorded. We have recordings of millions of transactions, and interactions. The other thing is really on how do you see this advancing the productivity aspect of the business, and do you see this as sort of the front end or sort of the resolution piece of it in terms of a customer interaction?
Yeah, so first of all, I totally agree with you because of the PII data. It's very difficult for engineering teams to get real data. And also, even if you have real data, it's usually very noisy. It's hard, like, because if you build an agent, right, or build all these kind of automations, the data was collected based on the automation. If you build a new agent, your customer behavior will change as well. So that's one of the biggest reasons that we built the simulation, so it can actually be more dynamic in terms of change. And of course, training is always a thing that people want in order to reduce the consumption of large language models cost. For example, if there is a very simple things about sentiment analysis, do we wanted to run large language model, which is very expensive and could be very slow. if we have a specific domain, so understanding very limited intents, right? Can we actually just build a very simple, small intent models to do that? Coming to the other in terms of is, I think like for agents, it's not just front-end automations, but also back-end automations. Back-end automations are mostly talking about workflows like documents, processings, and calibrations, or these are definitely a lot of things we can see could improve productivities. Because, for example, just look at like a reinforcement learning. You can use it for collecting how users are doing it by real humans and try to automate, do process mining from this in order to find the most efficient way to process it. Let's take like a reimbursement. You would have so many different steps. If the agent can automate most part of it and then only request information when it's a critical decisions.
Thanks. I have one more question. Sorry. One more is uh, one area that I kind of listening to your simulation. It just seems fascinating that one of the problems is not the easy cases, but the difficult ones. So if we actually had a simulator that can interact on difficult cases, that simulator would be great in terms of training. This is the human side, let's say, or even the agentic side, that the simulator itself can provide a lot of value in learning and training and all the rest of it. I'm wondering if you've gotten into that area. I'm not sure if I phrased my question properly, but the simulator does a lot of interesting things, especially in problem mode, that you can look at sort of these scenarios where the conversation or the customer service goes off the rails and kind of spot that and interact or intercept it at the right time.
So we don't really do training at the moment.
Okay.
Mostly is that it's relatively expensive to train things. And then most of the enterprises hasn't gone into the step of training. But we do think like when people are going off the, oh, we just wanted something to work, into we wanted to calculate ROIs to see if it's actually cheap enough to be actually using in a scalable way, then people are going to think about smaller models.
Thank you.
Thank
Great,
you
thanks
so
so
much. Thank you,
Bye.
everyone.